everyone, this question is about differentiation. The equation of a curve is find dy dx. So usually when we find dy dx, we just find the y prime because it's explicit. We can use explicit differentiation because we always have y equals something in terms of x. But this time we cannot rearrange this equation to get y equals something in terms of only x. So that's why we have to use something called implicit differentiation, in which we differentiate both sides with respect to x or y. We get same final result in the end. So here we are differentiating both sides with respect to x. Now when we differentiate x cubed, that's simple as usual, we get 3x squared. Now when we differentiate y cubed, well, it's similar, so we have 3y squared, but since we are dealing with different letters, this is y, with respect to x, we have to multiply by dy dx. Now, for the 2xy, this is a multiplication, we have to use the product rule. So this is the product rule. The du dx is u prime, the dv dx is v prime. So the formula is u prime v plus v prime u, just like this, u prime v plus v prime u, the product rule. So now we set the u to be 2x, the v to be y, the derivative u prime is just 2, so this is u prime, the v is just like this, and the v prime, the derivative of y with respect to x, so that's just 1, because just like the derivative of x with respect to x is 1, but because we have different letters, we have to use dy dx. So this is the v prime, the u is still 2x. So we're done with the differentiation. Now we just simplify here. So this is actually 2y, this is actually 2x dy dx, and we can move these two to the right, so it's minus, and we can factor out the dy dx, and we divide both sides by this guy here, and we get the final answer. Okay, so we pull out the minus here. Make sure you know that this is the same as this guy here. Okay, next part. Tangent to the curve at the point where x equals 0 and where y equals 0 intersect at the acute angle alpha. Okay, so we don't know the shape of the curve. We only know this is the equation, and we know this is the dy dx previously. So let's say the curve is like this. This is a totally random, unrelated kind of curve, just to visualize things. So where x equals 0, when y equals 0, that's x-intercept, y-intercept. So the tangent at the x-intercept and the tangent xy at the y-intercept, they form this angle called alpha. Now this angle beta can be found using the gradient. Gradient means the dy dx. Okay, so we can find beta, we can find gamma. Now if this is, we call it gamma, this reflex is, well, I mean the supplementary is 180 minus gamma. And using the sum of angles in a triangle is 180, the alpha would be 180 minus beta minus 180 minus gamma. So if we simplify this will be minus beta, 180 minus 180 cancel out, and we have plus gamma, so gamma minus beta. Okay, so the angle alpha is gamma minus beta. So if we're looking for tangent alpha, there will be tangent gamma minus beta. So we can use the compound angle in the MF19, because we are using tangent A minus B, we are using the symbol below, so tangent minus tangent all over 1 plus tangent tangent. So we're going to use this formula, tangent minus tangent 1 plus tangent tangent. Now what is tangent gamma and tangent beta? So tangent gamma would be the gradient of this tangent line. So I'm going to call it my. So the gradient passing through the y-intercept, that's tangent gamma. And tangent beta is the gradient of this tangent line passing through the x-intercept. Let's call it mx. Okay, so we need to find the my and the mx in order to find the value of tangent alpha. Now how do we find the mx and my? Let's focus on the x-intercept for now. So at the x-intercept, because it's x-intercept, it's gonna be something comma 0, the y must be 0. So you replace the y with 0. This is 0, so we have x cubed equals minus 8, x equals minus 2. So we can find the gradient. Just plug in x equals minus 2 and y equals 0. Minus 2, 0, we get, use a calculator, we get the gradient. So this is the gradient of the tangent line of the x-intercept, passing through the x-intercept. Okay, so now for the y-intercept gradient, same concept. This time we replace the x with 0, so 0, 0, the y is actually minus 2 also, and we plug into the dy dx formula to get the gradient at that point. So the gradient at that point is 1/3, so we have my mx. Just plug in the values here, use a calculator, we get something negative. Now in case you are wondering why is it negative, if we are looking for the acute angle, it says here the acute angle. So since we have no idea the shape of the curve and the tangents, if we're doing it this way, we might get the obtuse angle. So it's just 180 minus the acute angle. So if we're looking for the tangent, just use the absolute value or the positive value to get the acute value of tangent. Okay, so the final answer is positive 4/3. Alright, that's it. I'll